Here's example 5 of solving trig equations. So here we have cosine of theta equals negative 0.89, and same instructions as always so far. Part A, solve in the interval 0 to 2 pi, and this interval like this means 0 is less than or equal to theta is strictly less than 2 pi. And then part B, find the general solutions. Okay, so cosine of theta equals negative 0.89. We're going to start this the exact same way we did the previous example by drawing the unit circle, and then eventually we'll want to use some symmetry properties. So x-axis, y-axis, put a big old unit circle in here. Okay. Now remember, cosine of theta is negative 0.89, so remember that if the cosine is negative, then the corresponding angle is somewhere in quadrant 2 or quadrant 3. Because remember, cosine corresponds to the x-coordinate, right? So if we have some angle theta that's in standard position, then the terminal side of theta hits the unit circle at some point, and the x-coordinate of that point is the cosine of the angle theta. Okay, so if cosine is negative, the x-coordinate's negative, so we're in quadrant 2 or quadrant 3. So that's going to be somewhere over here or somewhere over here, approximately. Okay, we just want to make sure that we get the quadrant right. Okay, so here's one angle here. We'll call this one theta sub 1, and then we have another one over here. This angle here, we'll call that theta sub 2. Okay. Okay, so how do we get theta sub 1? Well, we can actually just take the inverse cosine directly. So theta sub 1 equals the inverse cosine of negative 0.89. Why will that work? Well, the inverse cosine, if you take the inverse cosine of a negative number, that's going to put you in quadrant 2, which is exactly where we want to be to get this angle up here. So the inverse cosine of negative 0.89 is going to get us this angle right here that we want. Okay. Or really, this is the angle here. This is the terminal side, this is the angle right here. And this is the one we want for that quadrant. So we'll toss that into a calculator later. But for now, let's talk about how to get this angle, other angle theta 2, okay, theta sub 2. So this is how we're going to do it. We're going to use symmetry properties again. And notice from the symmetry properties, this angle here and this angle here have to be exactly the same. Okay, they're exactly the same size. But this angle here, what is that? That's theta 1. Okay, that's the angle that we call theta 1. So this angle here and this angle here, just because of the symmetry here, this mirror image that's going on, this everything up top is being kind of mirrored below. So this angle up here is exactly the same as this down here. So this is also theta 1. Okay. So what we're going to do then is go all the way around the circle. That's 2 pi. Okay, if we go all the way around the circle, let's zoom in a bit. That's going to be 2 pi. Okay, so let's say 2 pi. And now let's add to that. So we're going to go around 2 pi, and then let's go back along this angle theta 1 in the opposite direction. Okay, let's maybe draw that somewhere else. So if we go back, so here we're going to go around 2 pi, and then we'll go back this. Okay, well, if theta 1 is this in the positive counterclockwise direction, then the same size angle in the other direction is going to be negative theta 1. Okay, so what we do is, actually this is pretty much identical to example 4. We're just doing 2 pi plus and then negative theta 1. And then where does that put us? Well, that puts us right here, which is theta 2. Okay, so if we go all the way around 2 pi and then back negative theta 1, okay, so go around 2 pi and then plus, add to that negative theta 1, that's going to put us right here, okay, which is theta 2. So if we simplify that, that says theta 2 equals 2 pi minus theta 1. And we know what theta 1 is. It's the inverse cosine of negative 0.89. So this is 2 pi minus the inverse cosine of negative 0.89. Now we're ready to toss some stuff into the calculator. So let's go ahead and do that to see what these values are. Okay, so we'll pull out our calculator. Zoom in a little more here. And again, make sure that we're in the radian mode. And make sure that we do the inverse trig. So we want the inverse cosine of negative 0.89. And then we want to do 2 pi minus that. These are our two answers for part A in the interval 0 to 2 pi. So 2.6681 is one of our answers, and 3.6150 is another one. So those are the approximate answers there. So let's go ahead and write those down. So for part A, the answers are theta is approximately equal to 2.6681, or theta is approximately equal to 3.6150, we'll just say 615. Okay. So that's the answer for part A. Now for part B, find the general solutions. So same exact thing we've been doing, just take our answers here for part A and then add the 2k pi. So for part B, it's going to be theta is approximately equal to 2.6681 plus 2k pi, where k is any integer. And we've explained all the 2k pi stuff in some of the previous examples more thoroughly in example 1. Or theta is approximately equal to 3.615 plus 2k pi, where k is any integer. And again, the k just represents how many times you go around and around. So if k is 1, then this is 2.6681 plus 1 times 2 pi. So that just means go around once. If k were 3, we would go around 1, 2, 3 times. Okay. If k were negative 1, then we go in the negative clockwise direction once, and so on and so forth. Okay. So that's the answer for part B. And that's pretty much it for example 5 of solving trig equations.